let's talk about solving least common multiple problems. And again, the thing about these word problems is you want to be able to recognize when you can use finding the LCM to solve the actual problem. So we have two word problems here. The first one is what we call a calendar problem. And a calendar problem is a problem where it talks about something happens on one day and then it recurs every certain number of days. And then a different thing happens on the same day, and they want to know when is the next time both will happen on the same day again. The reason they're called calendar problems is because you can kind of sketch a calendar to solve them. So the first one we have is the school cafeteria serves pizza every sixth day. Okay, now we need to know that pizza is served every sixth day and tacos every eighth day. If the pizza and tacos are both on today's menu, how many days will it be until they are both served on the menu together again? So we want to know how many days until they're both on the menu again. And the way that we can solve this using a calendar is as follows. So I know that on the first day, and it doesn't matter what day it is, so I'm just going to let it be Sunday because that's the easiest place to start. So if they serve pizza every sixth day and they serve pizza on this Sunday, I'm going to count, and every sixth day I am going to put a P for pizza. So pizza, and then Monday is day 1, 2, 3, 4, 5, and then on the sixth day is pizza. 1, 2, 3, 4, 5, and on the sixth day is pizza. 1, 2, 3, 4, 5, on the sixth day is pizza. 1, 2, 3, 4, 5, and on the sixth day is pizza. And then my calendar runs out. I could make more boxes, but hopefully I won't need to. Now, you might be able to see that there's a pattern here, which would make it easier for you to place the letter P in the boxes. Can you see what kind of pattern it is? And do you know why that happens? Well, let's see. Now we have tacos. Now, tacos are served every eighth day, but we know that they will also be served on that first day, so I'm going to put a T, and now I'm going to count every 8 days. So I'm going to put a little blue, kind of a dot, just like I did with the pizza, except this is going to be every 8th day. So T is on Sunday, and then 1, 2, 3, 4, 5, 6, 7, and on the 8th day is tacos. 1, 2, 3, 4, 5, 6, 7, and on the 8th day is tacos. Oops, tacos, not pizza. Okay, 1, 2, 3, 4, 5, 6, 7, and on the 8th day is tacos, and that's what I was hoping was going to happen. Okay, so you can see that in order to answer this, you have to look for the day that the pizza and the tacos appears on the calendar the same day. And so how many days will it be until they're both on the menu again? Well, now we have to count. So the first day doesn't count because they're both on the menu. And we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and on the 24th day. So it will be 24 days until Both are on the menu. Okay, now that's a great way to see what's going on in this problem, but unfortunately, it really takes a long time. And so we are going to try and think about least common multiples. So if I look, I have pizza is every 6th day. So I'm going to put 6 for pizza. And for tacos, I'm going to put 8 because it's every 8th day. Now look what happens. I'm going to list all the multiples of 6, and I'm going to list all the multiples of 8. So I have 6, 12, 18, 24, 30. Now I'm going to list the multiples of 8. 8, 16, 24. Oh, do you see what happened? As soon as I get a common multiple, that will be the first or the least common multiple. So you see that the LCM is 24, and that is also the number of days until both will be on the menu again. Okay, so anytime that you see these calendar problems, anytime you're given 2 things that happen on the same day and they want to know how many days until they both happen again on the same day, or when is the next time. Okay, next is a big kind of calendar or LCM word. Okay, so whenever you see 2 events, or sometimes even more than 2, and they want to know the next time they will happen simultaneously or on the same day or at the same time, that is going to be an LCM problem. Okay, let's look at one more example. Okay, a man smiles at his wife every 4 seconds. Isn't he sweet? Okay, his wife only smiles back at him every 5 seconds. So the wife smiles every 5 seconds. And they want to know, when will both husband and wife smile? Oh, made another mistake. At each other at the same time. Okay? And you can say, when is the next time they will both be smiling at each other at the same time? And again, there's that word next. You may not see it in the problem, but if you can reword the problem using the word next, chances are it's an LCM. Okay? So what do we have here? The husband is every 4 seconds, and the wife is playing hard to get. She only smiles every 5 seconds. And so let's take a look. Let's do the multiples of 4 and the multiples of 5. The multiples of 4, let's list them. 4, 8, 12, 16, 20, 24. Hopefully that's enough. And then list the multiples of 5. 5, 10, 15, 20. Oh, we don't have to go any further than that. And so hubby and wife will smile at each other. Whoops. At each other simultaneously. Every 20 seconds. Okay, are there other ways of solving these problems? Yes, you saw one way was the calendar. We could list oh, the husband is at time 0, right? And then in another 4 seconds, so at 4 seconds, at 8 seconds, at 12 seconds. So you see, you can kind of think of it in terms of how many seconds, but that still brings you back to your LCM table. So this is another way in which LCM, least common multiple, is very useful